Second part, absolute value inequalities, greater than situations. Let's talk about greater than. Big idea before we start. All the steps are going to be the same as part A. But if you want this absolute value to be bigger than 26, anything inside of here isn't going to work, right? If the absolute value of 7, it's going to be smaller than 26, okay? I need my numbers inside the absolute value to be above 26 to make that true. But again, because my absolute value will turn negative values positive, I also can get numbers below negative 26 inside here. If that was negative 28 inside of there, absolute value makes it positive. Positive 28 is bigger than 26. So there's two sections of numbers that can make a greater than situation true. All right? So that's going to mean that greater than absolute values split into things like or situations from lesson 44. It can be less than, so 3p minus 7 can be less than or equal to negative 26. If I'm below negative 26, absolute value will push me above positive 26. Or 3p minus 7 has to be above positive 26. Same deal though with your steps. So this really isn't like that's the only new thing, right? You don't necessarily need to watch all the way through this. Just know that add 7 to both sides, we get negative 19 here. Divide by 3 on both sides, we get negative 6.3. Repeating. Add 7 to both sides here, we get 33. Divide by 3, we get p is bigger than or equal to 11. Okay? My graphs are going to look like this for greater than situations. I need p to be 11 or more. Or I need p to be 6.3 repeating or below, right? So those are the two sections of answers that will make that true. And again, if you're not sure that you shaded the right sections, you can always try them with the original problem. I'm going to pick a number in the shaded region, like negative 10. 3 times negative 10 is negative 30. Negative 30 minus 7 is negative 37. The absolute value, positive 37. Positive 37 is bigger than 26. So this is good. Over here, pick a number inside here like 20. 3 times 20 is 60. Minus 7 is 53. Absolute value, still 53. That's bigger than 26. Good. Feel like you can do it? Hit pause, try against what I've got here. Okay, again, if I make that bigger than 50, obviously true. If I can make what's inside there less than negative 50, the absolute value will make it positive, and again, it will be true. Subtract 11 from both sides. X can be bigger than 39, or subtract 11. X can be smaller than negative 61. Smaller, bigger. All right, check this one out. Special circumstance. If I subtract 26 from both sides, we're going to have a negative number here. Negative 12. Okay? Remember, with less than situations, this was a problem. We can't make an absolute value less than a negative number. With greater than situations, we actually have the opposite problem, although it's not as much of a problem. I cannot pick an x to make this untrue. Every x, all along the number line is going to make this true, no matter what, because absolute value will make it positive, and a positive number is going to be bigger than a negative number every time. All right, so this would not be a no solution situation. This would be a all real numbers. All right, x can be anything situation. All right, so let's close out with a word problem of sorts. Probably the place that absolute value gets used most often is in precision, when you can have an over or an under on your manufacturing needs. All right, so planks come in a factory with a length L. That's going to be a variable. Maria must bind together a 3 centimeter base with 4 planks laid end to end. The margin for error allowed in our finished product is no more than 1 centimeter. What precision is necessary in the original plank lengths entering the factory if the finished product ought to be 5,425 centimeters. All right, there's a couple different ways that you could set up this situation. Basically, we have this 3 centimeter base, and then connected to it, we have 4 pieces. Each has a length L. Okay, so my total length then is going to be 3 plus 4 times L, right? That'll be the total length of my finished product. Okay, we're allowed to have no more than 1 centimeter error. We're supposed to be this big. Okay, so I could write a compound inequality, but because we're talking about absolute value inequalities right now, I'm gonna do this. I'm gonna subtract 5,425 from my length. Okay, and then I'm gonna put that in absolute values. All right, so if my length is bigger than this, I'll get a positive number, return a positive number, no problems. If my length is smaller, it's still going to give me a positive number. It's going to tell me whether I'm more than 1 centimeter off. All right, we want to not be more than 1 centimeter off, so we want our error to be less than or equal to 1 centimeter. And that would be the problem that I could set up to solve. All right, so breaking that into 2 pieces, we of course have, let me just roll up top and start writing over this. We've got 3 plus 4L minus that is less than or equal to 1, or 3 plus 4L's minus that can be greater than or equal to -1. And then you just go through your steps to solve it. So add this to both sides, subtract 3 from both sides. We're going to get 4L's is less than or equal to 5,426 minus 3, 5,423, or 4L's is greater than or equal to 5,424 minus 3 would be 5,421. All right, then we're dividing by 4 on both sides, and we have L is allowed to be less than or equal to 1, 3, 5, 5.75, or L can be greater than or equal to 1, 3, 5, 5.25. That's my answer. All right, all of the lengths coming in to the shop in order to guarantee we have an output within 1 centimeter of what we want. All of the incoming lengths need to be between 1,355 and a quarter centimeters and 1,355 and 3/4 centimeters.